Hi, my name is Hui Yan. I'm a first-year PhD student within the engineering department, and my PhD is titled 3D Printing Soft Robotic Grippers for Automated Strawberry Harvesting. So a bit of background, strawberries are considered to be the most valuable fruit within the UK, but one of the problems we're facing is that strawberries are commonly harvested by hand, which is a very labour-intensive job. And within the past few years, there's been a consistent decline in the number of available pickers. Therefore, there's a really strong need for an efficient robotic gripper for strawberry harvesting, which is what this project will investigate. So the focus of my research is upon the design of a soft robotic gripper for strawberry harvesting. We've seen that with standard rigid grippers, they're very non-compliant, they're not flexible, they can damage the fruit. With soft robotic grippers, we've seen much more promise in the sense that they're much more compliant and flexible, and you can actually 3D print them, which is great because you really open up the design space. But one of the problems we're still seeing is that with these types of soft robotic grippers, they're commonly pneumatically actuated, which requires really bulky apparatus. So we want something that's even more versatile, which is why I'm looking into a special type of smart, soft, stimuli-responsive material that can be actuated through heating or shining light upon it, which really cuts out the need for any sort of bulky apparatus. And with this particular material, it's also 3D printable, which is very nice. And in previous works, it's shown large actuations. So the potential of this material to be used within grippers is huge. The Dyson Foundation supports my project through several ways. So firstly, the connection we have with industry is great because that makes your research much more application driven. But also from my perspective, having access to the beeswax Dyson farm is just really helpful because I get to see firsthand what sort of challenges they face when they're hand picking and then think about those within my design. Also, having a Dyson mentor is also fantastic because they're there to help you not just from a technical perspective, but also from a career development perspective.
Hi, I'm Jack Foster and I'm a first-year PhD student at the Department of Engineering here in Cambridge. And my project is motivated loosely by the fact that farmers are working on really tight margins. And so there's a real desire to make sure any autonomous agents, such as robots and machine learning, they need to be really trustworthy to be able to overcome new problems and new challenges in a way that the farmer can trust. And as a result of that, we're trying to actually come up with ways where they can keep learning without relying on humans, but in a way the farmer knows is robust. So the title of my research project is Uncertainty-Guided Collaboration in Deep Reinforcement Learning for Knowledge Extraction and Sharing. And essentially, the idea is, can we have robots or machine learning agents learn, and then when they're uncertain and when they're not sure about a new challenge, can they learn from each other and share that knowledge so that they can overcome challenges they haven't yet faced? And in addition, can they do so in a way that the farmer can understand so they're willing to put their livelihood on the line and trust our agents? So the James Dyson Foundation supports me in a number of ways. First of all, having access to the Dyson farms is really valuable in terms of seeing what problems exist and how I can solve them. In addition, being able to go and present to industry is really valuable because it improves my communication skills and helps me better interface with complex problems. And finally, having an industry mentor is really valuable because it allows me to see how my career can progress and how to get there.